This week in Grace's Girls Club, heading into something of a new field for us here at GGC, I want you to meet Noriko from iExpressGenes. Noriko, welcome to Grace's Girls Club. So glad you're here. Please introduce yourself, tell us where you work and what you do.
Thank you for the opportunity, Grace. I'm Dr. Noriko Inoguchi. I am a senior lab associate working at iExpressGenes at Hatsanova Biotech Company.
Absolutely. Oh, I'm sorry, go ahead.
Go ahead.
No, you take it.
So my job is basically a researcher. They started in the lab and in a lab. So what I do every day is doing a experiment, design experiment, optimize experiment. So my day could be like one day doing experiment all day long. Some day try to have the opportunity to talk with scientists or reading papers. That's what I do. And also I'll train anyone coming new so that they can actually perform the experiment that we conduct in a lab. And because I do the experiment, I have to think about everything is well maintained. For example, instrument has to be maintained, make sure I have enough materials in it. So that's my daily life.
Wow, that is so cool. So you kind of have your hand in some pretty intense stuff and a lot of it. So of the letters in STEM, science, technology, engineering, and math, I would imagine that more than one of those applies to you. Which would you say you use most?
I'll definitely S part, the science.
Okay. Is there a lot of technology in there too, maybe some math?
Math is true. So technically for daily life, I use all STEM like literally because as the science part, because we need a knowledge, something you learn in the past, something I am learning, apply. That's a science part. And of course, engineering part matter because all the instrument we use, especially in biology, we cannot see any reaction directly. So we depend a lot on engineering side and technology. And of course, data has to be analyzed, so math involved. So technically, I use all the STEM actually.
You sure do. That's awesome. So walk me through iExpress mission. I think a lot of people are pretty familiar with Hudson Alpha, but what exactly is the cutting edge material that you guys are working on?
So iExpressGene is interesting in mental health. So a lot of time, mental health is very subjective and it's very difficult to treat because one of the hurdle is the person who is suffering have to say exactly what they're suffering, which is very painful because it's very subjective matter. And what we wanted to do is using some biomarker in the body, it's something produced. When we detect something produced, which could be a sign of you developing a mental illness or a possibility, that's what we wanted to see, to give it sort of a sign instead of like someone waiting until the very end to the point that really difficult to cure. Let's find out before things can be developed. So that's the type of work we are doing at IXG.
Very cool. So you said you're testing data and everything. Exactly what types of data would you get in that you would need people to, like you said, express almost perfectly what they're experiencing?
So what we are collecting is basically a blood sample, and then there's a biomolecule called RNA. I don't know how many of you are familiar with our body. Everybody has DNA. That's a building block. It has every single information. Then the protein is the type of macromolecule that actually do work. All the production, everything is managed by protein. And in between, there's another molecule called RNA. RNA is something transient. Depending on how you feel, what's needed for your body at the moment, that can be produced, reduced, and upregulated. We use the word upregulated or downregulated. What we try to detect is once we get the blood sample, collect the RNA, and what kind of RNA, how high it is relative to per se healthy group to see whether maybe you are too high on this particular marker, telling you maybe start developing stuff. So you might need to think about, for example, eating healthy or maybe thinking about further treatment. So that's what we are doing.
So that's incredibly cool. So you're basically taking a blood sample to find mRNA, measure that mRNA, and then give people practical tools like eat healthier, exercise more, maybe sleep more, maybe drink more water, and say, if you do this, it's likely going to decrease your risk of having a mental illness down the line. Is that correct?
Yes, that's perfect. Perfect.
That is so cool.
I'm glad, like, because that's why I'm so excited about being able to join this company, be able to work.
Absolutely. I mean, you're making a real life change and you're making it on the proactive side of it, which is incredible. And think about, like, from a family standpoint, if you treat one person in the family and you say, okay, this is what you need to do to live a healthier lifestyle, they're going to tell their friends and their family. So even by just analyzing one person, you've maybe helped like 5, 6, 7, 8 people.
Exactly. This will be the start of conversation. Just, let's try because we are not asking anything subjective. Can you just take a blood sample? We're not talking about a lot of blood sample. Just that it's like small enough that because we wanted to do as little amount as possible because not many like to get a blood sample
Hmm.
that easily. And we try to do at home collection too. So let's
Well,
try to make it easier. That's what we wanted to do.
and it's so helpful because, like, I'm thinking about my own life. It ebbs, like, if you would ask me, like, do you exercise enough? I would say probably not enough, but probably close to enough. Because I have some weeks where I exercise a lot, some weeks where I won't at all, and kind of everything, my sleep, my water intake, my nutrition, it kind of is up and down a little bit, not very large, but it kind of ebbs and flows. So it's difficult to gauge on your own, like, am I truly getting enough sleep? Am I truly drinking enough water? So for you to look at it scientifically as something inside my body is my genes, you can say, yes, you are, no, you're not. And that's information that can help me.
Right, because that's why we wanted to stay with RNA because that's something can change. DNA is something like we should not we just born with. It's there. It's almost like permanent. But RNA is something can change. That's why if we try to detect something, changeable, which means we can actually give it sort of it could be change, I mean decrease, increase. We wanted to detect something to give information that you can change.
Right.
Because otherwise, kind of depressing information that you get, sorry, you have this permanent marker that you're born with, which is very sad to me. I mean, when I try to, share the information to others.
But you can kind of also be there to say, but here we go, we can help you with that.
Yeah.
How cool. How cool. So you may feel like we've just touched on it in this whole conversation. If we have, you let me know. But tell me what the best part of your job is.
So definitely when things work out the way I thought it's going to be. So my work, of course, it's anything, everything is a molecular, which means you cannot see anything. Everyday life, I'm staring at the small droplet of clear water looking solution and everything's supposed to be happening. So when all I need to do is I need to basically fill those invisible part with my knowledge to see, I think this has happened, therefore this is okay. Everything is indirect. Therefore, when I plan and things work out the way it worked out, it just so feels good. Yes, science worked out. So that's the great feeling I have with my work.
That is a great feeling. And you know what? The trial and error of science is very real. Getting a
Mhm.
win is to be celebrated.
Exactly.
So if that's maybe the best part of your job, what is one of the most challenging portions of your job?
So that's kind of like a same feel because since I have if I let's say doing an experiment and I'm having an issue, then what happened is, of course, I cannot just Google to find the solution. It's not that simple because the problem is layers and layers I need to decipher. So that's a challenging part is how to look and where to look. The answer could be everywhere. Just my answer could be like multiple sources I need to look and find out. So that's why how to find the solution, what to do, it's gonna be could be challenging. For me, it's like that's part I enjoy. So it's challenging, yes, but it's a part of the reason I enjoy and have a degree and have fun with it. So it's kind of like interesting balance for me when I describe like a challenging part of my work.
Oh, absolutely. I mean, it's definitely, it sounds like the most difficult part, but it also keeps you engaged. So
Right.
when you were, think back to the girls who are going to be watching this, who are in
Mhm.
Grace's Girls Club. When you were in middle school, high school, maybe very early in college, what exactly was it that drew you to this field?
So it's really started with lecture. So I have a general interest in biology because I like to watch, let's say, the medical field related drama or things like that. Very general interest in biology. And it didn't happen until I actually took a college and introductory biology class. It was still fascinating. I really appreciate the faculty still that what he said was the shape of biological molecule matters. It's just like daily life. I kind of use the example of car tire. At first, a car tire has to be round because otherwise it'd be very uncomfortable, right? The same thing apply to all the molecule inside of the body. It has shape because it has to conduct the function. And that was so fascinating field to me. Then that's where, when I first talked with the faculty, tried to find like, oh, I was so fascinated. I wanted to learn more about it. And that's how the driving force for me to wanting to work in the research lab. Then I wanted to continue getting further degree and go to grad school, get a PhD. And I still keep that passion right now. Like everyday work is just always remind myself, yes, I love what I'm doing. Things are challenging, but still what I'm doing is so related to what I was initially passionate about.
Oh,
So.
yeah. And I totally relate to that. I mean, I chose meteorology for physics, you know? I mean, I liked weather. It was great, you know, whatever, but I had no strong feelings about it. It was the physics component that I loved, and that led into me being really passionate about weather. But it started kind of in that one class, very similar to what you're talking about. So walk me through, oh, my question just went right out of my head. So we talked about why you chose this field. Oh, yes. Walk me through educationally how you got to where you are today.
Sure. So I started with college, 4-year college, and I started science. And then since my interest more toward the molecular, so I was doing more biology emphasized, but still have to take chemistry, have to take a physics. So 4-year college finished. And after that, I directly went to the grad school for PhD program because one thing I wanted to have was being independent scientist. And then going to the PhD is that's how you be trained. You'll be independent scientist. You're not going to know everything, but you need to know the solution. You are so specialized in certain thing. That's how I was trained. So 5 years I did PhD. And after that, a lot of time people go to what's called postdoctoral researcher because you just got degree. Now you need to practice. So I went through the postdoc, we call postdoc for short period for the industry and also academia. And here's actually UAH. And then, then I finally coming back as the full scientist in this company.
Wow. So really quick, you did 4 years of undergrad,
Mhm.
5 years of PhD program, and how long was postdoc?
So it's totally, let's say, to probably, let's see, 5 years or so total. Because a lot of time you do about 2 years or so in different location.
Okay.
Then you train. Then after that, some people become a faculty. And I'm more interested in be in the lab. That's why I choose to be a researcher. And then that's how I got my position now.
So after high school, you did 14 years more of school?
Yeah, yeah, I guess so. That's a lot of schooling.
Girl, you got more guts than I do. I couldn't have stayed an extra hour, and you stayed 14 years.
That's, it's interesting because the some people actually wanted to take a break,
Yeah.
in which in fact I did. Like after 4-year college, I took a break almost 3 years before I entered the grad school because that was the time I was actually trying to see whether I liked the field or not by just going to an internship to get a job because you may be passionate about certain thing, but you never know until how much you like it until you see the type of work you do. So, uh, some people are actually, be tired of being at school for long, but in the fact that I'm still, I mean, have a research lab in the university, so I'm kind of still feel like a student, and people think I'm a student too because I'm just in the lab all day long. This is not something what people usually see as a PhD holder. So.
So were all of your degrees, did those come from UAH?
No, actually, it's at first I started with Missouri when I first started, and then went to Nebraska for PhD. And then I did postdoc at UAH because one of the advice I got from professor, the basically who made me interested in the field, is try to move different location. This just tests whether you actually have a skill or not. Because when you try to do experiment or if you do something, you never know how many support actually you have around. Because I know, because I'm original from Japan, so I know what it meant by having family when I was at college. Then when you go to different university, now I thought I can do this experiment, but at least it was because I have resource, I have people helping me. So that's why I intentionally move around so that I can just kind of train myself so that I know what kind of skill I have.
Yeah, absolutely. I mean, at that point, you're just doing it all on your own. So I know you're busy. I know you have a lot to test and people's lives to change. So I want to let you get back to it. But before I do, one more question for you. If you had a message to young girls, young students in general, that wanted to join the STEM workforce, what would your message to them be?
Probably just be always curious about or wondered about stuff, because the research is not going to start without having idea. Idea is always start with someone's curiosity or why. Then passion, and also every day, for example, for me, is try to troubleshoot is always curious about, wondered around. So just I want everybody to feel always curious about what you're interested in right now, and then you'll be surprised how much it meant, especially when you're facing some challenging situation.
Spoken like a true scientist. Keep asking questions.
Yeah, I mean, it's really true, because ask a question. I don't know how probably my professor get tired of me asking question for everything and stuff, because I wanted to know, I'm curious about. I do the same thing for now when I do the experiment, that why, going back to textbook, going back, I mean, really, I don't know how many times I went back to textbook and study
Oh,
after
it's
I
so
finished
true.
the degree.
It's so true. I
Yep.
keep my differential equations book right here in the studio because if we ever get something that's not, completely ordinary, if it's something I haven't seen in a couple of months, I'm like, okay, pull that back out. What are we looking at?
Exactly.
Now, do you do this with your friends? Because my friends will say all the time, Grace, you're interrogating me. Stop asking me so many questions.
I probably do more with the graduate student, because I also work in the research lab at university, so I see a lot of student. That's why I probably mostly doing like the graduate student who are in the field. It's always fun.
Very, very cool. Well, Dr. Noriko, thank you so much for your time. Thank you for sharing this with us. I can tell you without shadow of doubt, the girls are going to love this.